Even though we use AC for a lot of our household appliances, we use DC for things like portable flashlights or radios or our phones. Really, anything that has a battery is running on direct current, DC power. And since we're not connected directly to a generator, that DC has to come from a storage device. And the energy storage device, or an energy storage device, is called a battery. A battery has a negative terminal called the anode and a positive terminal called the cathode. The anode is typically, okay, there are many different kinds of batteries. There are a lot of different ways that batteries can be constructed. There are different combinations of materials that can make batteries, but generally speaking, every battery is going to have an anode and a cathode. The anode is the negative end, the cathode is the positive end. And the battery technology has advanced by leaps and bounds in recent decades. But there's still, uh, generally speaking, there will be an electrolyte filling most of that battery. The electrolyte is a substance that conducts current, but it doesn't conduct current like a like a wire does by pushing and pulling individual electrons. It conducts current in the form of positive and negative ions. So an electrolyte is some mixture of positive and negative ions that can carry current between the cathode and the anode. The anode is typically made of a metal that will give up electrons. Remember, metals don't hold on to their electrons very well. Or at least their outer electrons are free to flow from one metal atom to another. So the anode is made up of some kind of a metal that easily gives up its electrons. The cathode is made up of a metal oxide that will accept electrons. So metal oxide is a molecule or an ion that's made of the some kind of metal covalently, well, some kind of metal bonded to oxygen, and it will readily accept electrons. So the electrons are pushed in one direction. They flow in one direction in a DC circuit. Again, DC is not going to work over super long distances very well. It loses the longer the wire is, the more energy is going to be lost. Batteries are not the only things that use DC current. Solar panels also use DC because remember, with a solar panel, you don't have that rotating magnet that you have with a generator, where you're going to have the poles constantly switching. With a solar panel, you're just absorbing the solar energy and it's flowing in one direction. So if you have solar panels on a house, for example, then that DC current from the solar panels has to run through another kind of transformer and be converted from DC current to AC current before you can use it in your house. So a battery is using what kind of energy? Well, it's got this energy stored in chemicals. So it has chemical energy that is converted into electrical energy. Rechargeable batteries are able to reverse that process. The electrolyte is the conductive material that carries electric current between the cathodes and the anodes. So think about how electrical energy can be stored and how can a device do this, because electrical energy has to be stored in some other form, right? We can't just store electricity. Electricity has to be used as as it's available. So if we're going to store electrical energy, one way to do that is to convert it to chemical energy and store it in a battery. There are other ways you can store it in mechanical energy if you and then convert it back to electrical energy. In recent years, you've seen in the news more. Our energy demand has increased. Okay, not only because the population in certain areas has increased, but also because we use more electronic devices, more electricity, and so at certain times when we have increased demand here in California, we see during the summer when a lot of people are running air conditioning, we see more and more blackouts, rolling blackouts, and brownouts. So a blackout is where you actually just lose electricity on the grid, and it has to be restored. For a rolling blackout, that that loss of electricity is usually planned, or so often you'll be notified, and it's temporary. But when the grid is strained too much, some people lose their electricity for a short period of time because other people are using it. So the rolling blackouts move from one location to another, and they can be pretty inconvenient. A brownout is not a complete loss of electricity, but it's a decrease in the voltage that's available. So we're seeing more and more rolling blackouts where we'll just be informed, okay, during this time period, you're not going to have electricity available, and then we're able to plan for it, and uh, we can know that we're not going to have electricity available during that time, and it's not great, but um, sometimes it's necessary because the grid hasn't been developed to provide all the power that we need. So, what are some possible benefits and drawbacks of virtual power plants? Well, a virtual power plant is when many different sources, different types of power plants are combined on the grid to produce a reliable source of electricity. So, for example, our grid is becoming more and more dependent on things like wind power and solar power. Well, if you had a grid that was totally dependent on solar power, then when the when you don't have enough sun to supply the grid with power, it would only last as long as your batteries, and then you would have blackouts. If we had a grid that was totally dependent on wind power, then if the wind isn't blowing, you don't have electricity. So in a virtual power plant, we design we connect different kinds of power plants, so, and then they are interconnected, so they provide energy from multiple different sources. So if one source of electricity is not doing its share, then other energy sources are able to hopefully make up for it. So virtual power plants are made up of many different sources of electricity. One other interesting type of uh, virtual, or one other interesting type of energy storage is, we've talked about dams and how hydroelectric power supplies our some of our energy needs. Well, when you have excess electricity, one thing you can do is use that electricity to power a pump and pump water back up into behind the dam, into a reservoir behind the dam. So you can, if you have excess electricity, then you can resupply the dam, resupply the water source behind the dam. So then when you need more electricity, you can let that same water flow back down through the dam. And in this case, your reservoir of water is kind of acting as a battery for your electrical grid. Remember, a battery is any kind of energy storage device. So if we're storing chemical energy, then that's a battery. Or if we're storing electrical energy, if we're storing energy as chemical energy that we can turn into electrical energy, that's a battery. But if we're storing energy as potential energy, gravitational potential energy that we can then convert into electricity, electrical energy, that's also a type of battery.